Bismillahirrahmanirrahim. In this lecture, we are going to speak about the properties of the definite integral. And as we defined before that, we said that the definite integral is equal to the limit of the Riemann sum as n goes to infinity, where the given function is continuous over closed interval a and b. Using the properties for the definite or, just define the properties as the first one, we say the definite integral b to a f of x dx equal to minus integration a to b f of x. Said that if we reverse the order of the limits from a to b and b to a, then we have to multiply the integration by negative. So a to b f the integral from a to b f of x equal to minus integration b to a. This is the first one. Now if a equal to b, then the integration from a to a is equal to 0, because delta x in this case will be 0. We know that delta x is equal to b minus a, but if b or a equal to b, then a minus a is equal to 0. So delta x equal to 0, which means the definite integral itself will be equal to 0. Now, if we have constant function, the integration from a to b of the constant dx is equal to cb minus a. This can be explained clearly that if I have a constant function y equal to c, then we will have a regular shape. It is rectangle. And the area of the rectangle is equal to c multiplied by b minus a. This is a very clear case. For the second one, if we have sum of two functions, the integration from a to b f of x plus g of x, then it is equal to the sum of the two integrations. Third one, if we multiply the function by constant, we can take the constant outside the integration. So it is equal to c multiplied by the integration of a to b of f of x dx. And similarly, if we have negative or subtraction of two functions, then the integration of the subtraction equal to the subtraction of the two integrals. That will be integration of f of x minus the integration of a to b of g of x. Sometimes we need to break the interval into three parts. If I have function defined over a to b, and we have a constancy between the a and b, then the integral will be as a sum of two integrations. So we can say that if the integration of a to c f of x plus integration c to b of f of x equal to only a single integration, definite integral from a to b. We can take the whole interval of the same function f of x dx. For the comparison properties, if we have f of x is greater than or equal to 0, to me it is non-negative function, or the function is above the x-axis or equal to or on the x-axis. So if I have a function, positive function over a to b, then the integration itself will be positive number. If I have positive or non-negative function for all x between a and b, then the function itself or the integration of the function will be also non-negative or greater than or equal to 0. The positive function will give me the integration will be positive. If we have f of x is greater than g of x for all x between a and b, this means that if I have a function f of x and another function, say g of x, for all x between a and b, f of x is greater than g of x means in the graph, the curve of the f of x is higher than the graph of the g of x. So it is very clear that this area, if it is positive, later on we will say this is the area if it is positive, is much or smaller than the whole area. In the definite integration, we will say that the integration or definite integral of f of x will be greater than definite integral of g of x for the same interval a to b. So f of x is greater than g of x means the definite integral of f of x is greater than the definite integral of g of x. For the number 8, if we have a function f of x is restricted between lower bound and upper bound, or lower limit and upper limit. For a less than or equal to x less than b, then the definite integral of the function f of x will be greater than m times b minus a. Actually, this is the first property if we have constant function, and less than capital M times b minus a. To clarify the last property. So for that, we have this integration, and we need to estimate the value of the integral using property 8, this one. In the first one, question number 69, I need to find or to estimate the definite integral from 0 to 1 for the function x to the power 3 dx. Now my function is x to the power 3. And we know from the extreme value theorem, if we have a continuous function defined on a closed interval, then it has absolute maximum and absolute minimum. The graph for x to the power 3 is given by this function, or this curve. And it is continuous function. Since it's continuous, and we have interval 0 to 1, from 0 to 1, it is a closed interval. I have my interval AB is equal to 0 and 1. This closed interval. We have continuous function defined on closed interval. It means it has absolute minimum and absolute maximum. And in this interval, or on this interval, the function is increasing, which means the absolute minimum will be at the end, the left end of the interval, and the absolute maximum will be at the right end of the interval. So this function will be greater than the absolute minimum, which is 0 to the power 3. Is the value of the function at the left end of the interval, and will be less than the value of the function at the right end of the interval. So 0 will be less than x to the power 3, less than or equal to 1. Now the eighth property said that if we have a function restricted between the lower bound and upper bound, then the definite integral will be between m times b minus a and capital M b minus a. So the integration for this one from 0 to 1 of x to the power 3 dx will be greater than 0 times 1 minus 0, which is b minus a, and 1 multiplied by 1 minus 0. So it will be between 0 less than 0 to 1 x to the power 3 dx less than 1. So the estimation for this different integral will be between 0 and 1. For the next example, I have 17, which is, I'm sorry, I have different integral 0 to 3, 1 over x plus 4 dx. Now the graph for this one, we have vertical asymptote at x equal to minus 4, because at x equal to minus 4, the function is undefined. So the graph for this one, it will take this shape. I have vertical asymptote at x equal to minus 4. But my upper bound and lower bound is between 0 and 3. My interval is 0 and 3. Question number 17. On this interval 0 and 3, my function is continuous. It is continuous and decreasing. So I need to find the value at 0 and at 3. Since it is decreasing, so the maximum will be at the left end and minimum is at the right end. Now the my function, which is 1 over x plus 4. It is decreasing function, which means the minimum will be at f of the right end, continuous over closed interval. So I have maximum and minimum. Maximum will be at the left end because it's decreasing. This is f of 0. And minimum at the right end. Right end will give me minimum. Maximum will give me the left at the left end. Now f of 3 is equal to 1 over 7. Just replace x by 3. The 3 plus 4 will be 1 over 7 less than 1 over x plus 4 less than, replace x by 0, 1 over 4. So the definite integral will be 1 over 7 multiplied by b minus a, which is a 3 minus 0, less than the definite integral 0 to 3 of 1 over x plus 4 dx, less than or equal to 1 over 4 multiplied by 3 minus 0. Or just we can say it is a 3 over 7 less than the definite integral 0 to 3, 1 over x plus 4 dx, less than or equal to 3 over 4. So this is the estimation for the definite integral using that property. M or f is restricted between lower bound and upper bound.